Hello and welcome to Algebra. Today we're going to take a look at section 1.4, Order, specifically Order of Operations. If you'll recall, we started with addition, and then we used that to define multiplication, which we then used to define exponents. And the question we want to look at is, if I have an expression that involves all of these things, what order should I do them in? To answer that question, what we're going to do is we're going to take this expression here and we're going to break it down. To begin with, I'm going to take this exponent and write it in terms of multiplication. It's 4 times 4. And then we'll fill in the rest of the equation around it. Okay, and then this is where things get a little tricky. I'm going to take this multiplication here, I'm going to treat this as if it's in parentheses and rewrite it. So it's 4 times 4 plus 4 times 4 plus 4 times 4, and then I'll fill in the rest of the equation around it. But then I can break each one of these little guys up. Lots of colors today. Take that little 4 times 4, I could break it up into 1, that makes 2, 3, 4. 4 additions of 4. That's a lot. So we'll have, let's see here, 4 plus 4, this is going to be equal to 4, 8, 12, 16. So this guy becomes 16, this guy becomes 16, and then this guy becomes 16, and we're adding 5 in at the end. Okay, and we want to write everything in terms of addition. So this is 32, 48 plus 5, and that's 53. Okay. We've broken everything down into addition. We know that this guy better be 53. The question is now, what was the order that we went through? How would we do this without all of this ridiculous write it in terms of addition stuff? Well, we could try multiplying first. We get 3 times 4 is 12, so we'll write this down. If we try multiplication first, that's 12 squared, I guess, plus 5, which 12 squared is a gross, that's 144, plus 5, 149. That's way off. We can trust what we did here with all the addition, because we only had one operation. So, nope. That's not it. We could try the addition first. I'm not sure what we would add. Maybe it would be 4 plus 5, so it would be 3 times 9 squared, 3 times 81, 243. That's even worse. So that leaves us with exponent first. Oops. 3 times 4 squared plus 5. We're going to get 3 times 16 plus 5. This is looking good because we had 1, 2, 3 additions of 16. This right here is equal to 3 times 16. That's a good thing. So then do we do the addition or the multiplication? We just saw that we had 3 times 16 sitting in there, and we did that first to get 48 before adding 5. That means it's multiplication second and then last. Alright, so this is the start of it. This is our good start. But there's one other thing that we could look at that we need to figure out where to take into account, and we've got them right here. It's these guys, the parentheses. The rule is parentheses always come before everything else. So we could just say parentheses 0th. We'll just change our indexing there for our counting. So our order of operations, to write it out again, is parentheses, exponents, multiplication, addition. And I always call that PIMA. Add a little majesty about it. Now, some of you may know the old mnemonic, please excuse my dear Aunt Sally. Why PIMA? Why not please excuse my dear Aunt Sally? Well, the reason is that please excuse my dear Aunt Sally has dear and Sally in it. Division, subtraction. And one of the things that I really want to get across is that multiplication and division are the same thing. Addition, subtraction, the same thing. We don't treat one any differently than the other. We don't need to. So, I like PIMA because it's got that little reminder of, hey, multiplication and division, we treat them the same way. They follow the same rules, hidden right in there. Well, if you really, really want, I suppose you could probably get away with doing a little DS right there. But it doesn't flow off the tongue as well as PIMA does, so we'll get rid of that. Okay, so that means if we have something like for, oops, not x, 3 plus 1 squared minus 7, what we do first is the parentheses. Then we do the exponent. Then the multiplication. Let's see here, 4 times 16, that's 4, 64. Then we handle the addition, which in this case happens to be subtraction. And there we go. Parentheses, then exponent, then multiplication, then addition. PIMA. Now, one of the things that order of operations is extremely useful for, and that comes from order of operations, is the rules for distribution. So let's take a look at something here. Say we've got, 4 times 3 minus 1, we'll say. That's, according to PIMA, 4 times 2, which is 8. What I want to do is I want to find a way to get around this. I want to find a way to get rid of the multiplication first. And that's what distribution is about. Well, okay, why would I want to get rid of the multiplication first? Well, maybe I've got a situation like this, where I can't do this subtraction and I want to get rid of that multiplication. That happens a lot. So, we'll take a look at this right here. And we'll leave the x situation for now. We won't cover that. So we're going to take this guy, we're going to move it down here. That's 4 times something. So that's 3 minus 1 plus 3 minus 1 plus 3 minus 1 plus 3 minus 1. And this is all addition. Now it's all addition. So what we can do is we can rewrite this all in a better order. That order would be all the 3's together, and then all the negative 1's together. And then let's take a look here. We have 1, 2, 3, 4 of them. And then over here we have 1, 2, 3, 4, 4 of them as well. So this will simplify to 4 times 3 plus 4 times the negative 1. And when we perform those operations, we get 12 minus 4, which is 8. Huzzah! What we did is we took this 4 and we multiplied both 3 and -1 by 4, then we added. So it's almost as if we took this guy and we went doink, doink, and we hit both terms inside the parentheses with it. Multiplied both terms. That's how distribution works. So if we were to distribute this example over here, it would be doink, doink, 4 times x minus 4 times the -1. So that's 4x minus 4. And in general, we get, let's see here, distribution, we'll say a x plus y is equal to ax plus ay. And if we wanted to show that, we'd go through the same process. We'd say, look, this is x plus y plus x plus y, keep on going until we have a of them, and then we can rearrange it to be x plus x, so on, and plus y, and so on. And we're going to have a of these and a of these, which is ax plus ay. Hey, that's exactly what we said it was going to be. And if I just sit here and I do a little TS for to show, TS for to show, and then proof, suddenly I just did a formal proof. And I can go ahead and end it with a little character there called a tombstone. Occasionally this guy is just an empty box, or if you go really old school, it's QED, Latin initialism for it has been shown or it has been demonstrated, quod est demonstratum. But this is really fallen out of usage, and I like that guy. It just feels so good to color it in. So how would this work? If I had 2 times 6 plus 11, that's actually 2 times 6 plus 2 times 11, which is 12 plus 22. Hey look, 34. Okay.